Hadoop distributed file systems, what are the basic concepts, nodes, what is the data flow, what's the whole deal about parallel processing, archiving, what are RAGs, what are daemon processes, etc. Then we'll focus on MapReduce. It's an algorithmic technique for multiple CPU processing. It's very different from the sequential processing that we have been so far used to, how it works, and we'll go into the nitty-gritties of it. And then we'll develop some applications. We'll see how to set up, how to configure, and then we'll go into some more additional components like Pig, Hive, Scoop, HBase, Oozie, Flume, Zookeeper. So that's about the training curriculum. Let me switch to my PPT mode. Okay, so can all of you see the PPT, I hope? You can just ping me back in case you're not able to see, or even if you're able to see. Okay, good. I think Raj is able to see it. Anybody else having problem seeing the PowerPoint presentation, just let me know. Okay, then I'll assume that everybody is able to see, but just in case you have any problems, check with the organizers, and they'll help you sort out. Please feel free to ping me if anybody needs anything. Okay, so just for the sake of the demo, I'm going to unmute you guys so that as I go along you can ask me questions. So please feel free to stop me. Don't hesitate if there's any doubt or whatever you want to get it clarified, and we'll go through it. I just want to make it a very interactive session, and I'm going to explain to you what this whole big data hype is about, what is Hadoop about, and how things go. So I'm unmuting all of you. Just feel free to shoot questions as and when we go along. Thank you.
Unmuted.
Anything? Is it okay if you can just mute from your side so that everybody can hear clearly? Or yeah, thank you so much. I think somebody else has to mute. Thank you so much. Okay. Okay. Just let me know if anybody has any problems with the audio quality. Otherwise, I'll have to mute everyone. I think I'll have to mute. Okay. Cool. I think this way there won't be much disturbance. So please ping me as and when you have questions, and I will pause and answer your questions. Thank you. All right. Okay, so the first thing that you are seeing on the screen is the big data landscape. This is the first thing I wanted to show, what this big data is about. Basically, if you primarily see, you have concerns against infrastructure, you have analytics, you have plethora of applications. You have a lot of technologies, as you can see, SAP, SAS, IBM, the Google, the Oracle, Microsoft, and all the biggies in the world, who have come up with various products and various technology stacks to handle big data. So this is the whole bird's eye view snapshot. You could see technologies in the domain of NoSQL databases, new SQL databases. Then you have Hadoop related technologies, especially from companies like Cloudera, Adapt, IBM, Microsoft. Then you have a lot of other things for providing you clustering services, storage services, querying services, analytics, visualization, machine learning, etc. For a student or for a professional trying to take the big jump into big data, this all can be very, very intimidating. That's where we at Instant Learning Technologies actually come into picture. We help you bridge the gap between what is big data, what is Hadoop, and how you can get practical hands-on knowledge, to leverage this great opportunity. So this is what people look at, then they get confused. What are the job roles? How do I get in? What are the various stuffs I need to do? So I'm going to take you very smoothly into what this whole thing is about. Moving on, I would like everyone, to just take a couple of minutes and just focus on this picture, the different quadrants that are there about big data. So let's go in that. In the meantime, I would be, chatting with you. Just take 2 minutes. All right, so let me start off with this. Let's start with the first quadrant, just to make things interesting. It's funny in a way that today's smartphone would have been the most powerful computer in the world in 1985. It's like, okay, what's the big deal in this? But it's really interesting the way you look that today's smartphone, maybe your iPhones or your Samsungs or Android-based phones, all the smartphones, they can beat the most powerful computer in the world, maybe if you compare with the computer in 1985. That means smartphone or mobile platform is the primary gateway that's generating petabytes of big data. We'll see how and why mobility plays a very important role for big data and Hadoop. If you look at the second quadrant, which says, there are about 120 million people in the US who own smartphones, and just last year there were like 30 million people who started with smartphones. That is, penetration of mobile into the market is very high compared to your laptops, desktop computers, etc. Another interesting point, for $600 you can buy a disk that can store all the world's music. Now that's interesting. That means data in your pocket for just $600. That shows, another interesting trend which probably accelerated the whole concept of big data and Hadoop is memory is becoming cheaper and cheaper. I'm sure most of you are aware of the Moore's law. We'll talk more about it as we go along. A lot of us in today's world, we are into social networking, and the interesting fact is, there are 30 plus additional billion pieces of data that Facebook adds every month to its already, cornucopia of information. 72 hours of videotapes or videos are added to the YouTube every minute. Every minute as we speak, YouTube is amassing data, which is 72 hours of video. That's quite some data if you look at it from an aggregation from a monthly or a yearly perspective. By the end of year 2012, a certain company was actually capturing 1.4 trillion digital interactions per month. That's again very, very interesting. The most interesting fact of all these widgets here is this one. 92% of the world's digital data was just created in the last 2 years. Can you guys believe it? 92% of the world's digital data. That includes your pictures, music files, MP3s, videos, documents, you name it, maybe stored in your emails, maybe your likes and comments on Facebook, your shopping patterns on eBay, Flipkart, etc., etc. All this, 92% of this data was just created in the past 2 years. And this is an interesting challenge because companies now know that if they rule data analysis or if they have the edge over their competitors in analyzing and crunching data, they can actually, take control of the market, and we'll see how big data works. Another interesting point, more than 1.4 billion consumers are spending, 22% of their online time, and they spend their time on social networking platforms Social networking platforms are the primary gateways, that are generating this kind of, huge, humongous data. Normal interesting points overall, and we are living in a data age. The basic, gist of this whole slide is we're living in a data age where data is growing, not in terabytes, not in gigabytes. Data is growing in petabytes. Okay, you could, be a contributor to this data, both as a digital consumer and a digital data producer. Your review or your comment on Amazon.com on a particular book is data. Your like or your comment on Flipkart is data. People uploading videos, that is data. People uploading music files, that is data. So we are living in an era where we are inundated with data. Now when you are inundated with data, that technology or that tool or a set of processes that helps you make sense of this data will give you the edge over your competitors. In today's world, people are grappling with the problems of how to handle data at such scale. Now, what would you do? I mean, in general, I'll give you a classic example of what you would do. Let's say you wanted a powerful piece of, computing because you have a lot of data on your laptop. You probably go upgrade your RAM. You probably go buy some external hard disk, 1 terabyte or 2 terabytes hard disk, and use it as a secondary storage mechanism. So at the max, you can store 1 terabyte of information. Now let's say tomorrow, every 2 minutes or 3 minutes, you have additional 5 terabytes of information coming in. What would you do? You go running to the store, probably buy an additional external hard disk of 1 terabytes and 2 terabytes. But if every minute this data is coming and you don't want to lose this data, you want to persist this data, you have to keep on purchasing new hardware. The problem is not just solved there. Even if, okay, I just got a comment that I am not audible. I'm audible now. Can you guys hear me now? Okay, I'm sorry. Do you guys want me to repeat any of the points? Just let me know. Okay, so we are good. I hope this audio quality helps you work. All right, just ping me. Feel free to ping me so that I can repeat the points. So quickly to sum up, what I'm saying is, I just gave a simple example. Let's say you have data initially which was growing at 1 MB per hour. Okay, so if your data was growing at 1 MB per hour, you could buy a 1 TB hard disk, and that will suffice. That will store the data. So for 1 gig you will have 1024 iterations, and for 1 terabyte you'll have additional 1024 iterations. But what if your data was growing at like 1 terabyte per second? What if your data was growing at 20 terabytes at 1 second? You cannot keep running to the store to buy additional hardware to store this data. Even if, let's say, hypothetically speaking, you have the unlimited amount of hardware. Now let's say you want to query some data. You want to find some information out of this huge amount of data. What kind of technology would you use? How would you query this data? And if you ran a query against this data as to what John's comment was on iPhone 5 out of the millions of comments or billions of comments that you got, how long will a job processing that request take to complete successfully and provide you the data? Now this is the crux of the problem for all companies handling big data. Since we live in an era of social networking, since we live in an era where people spend almost 20% of their time online, the penetration of broadband is, rapidly accelerating. People are now using smartphones to, consume both digital data and produce digital data. Companies like Google, Amazon, Facebook, Walmart, and even small and medium enterprises are grappling the problem on how to store this data, and not just storing the data, but how to get intelligent sense out of this data. And this is the context of big data that we'll see further. So I hope I made it hopefully clear on what this whole big data is about, why 92% of the whole data being generated in the last 2 years is actually flooding companies' servers, and there's not enough hardware and not enough technology to actually handle this kind of onslaught. And we'll see how Hadoop helps overcome this problem. Okay, moving on to the next slide. I'll just give you a few seconds for you guys to quickly, take a look at this slide. This slide basically sums up what all I was talking about big data. Just take a couple of seconds, to run through this slide. Okay, so let me walk you guys through what we are seeing here. So we just spoke about big data a couple of minutes ago. This is a slide that sums up what is big data. So anything you quantify or qualify as big data has three attributes or three primary parameters: data that has volume, data that has velocity, and data that has variety. When all these three factors are very high, that means you're dealing with large amounts of data, you're dealing with data that needs to be analyzed quickly, you're dealing with data which is not of one particular type. It's not just an XML file, or it's not just text file, it's not just picture, or it's not just a video or a like or a comment. It could be data of any kind, any digitalized information. When data grows with that volume, that velocity, and that variety, and it's bombarding your enterprise servers, you have run into the problem of big data. The key questions that most of the enterprises that are doing business in the last 2 years are: how do I store and protect this big data? How do I back up and restore big data? How do I organize and catalog the data that was just backed up? And the most important question of all, this is where Hadoop comes into play, is how do I keep my cost or operating cost lower while ensuring that all the critical data is available when the enterprise needs it? This first column here sums up what is the characteristic of big data and what are some of the key questions enterprises ask about big data. Now, if you look at some of the pointers by some of the research organizations, the world IP traffic will become 4 times what it is now by 2015. By 2015, there will be 3 billion people who are online, and they're pushing data and creating and sharing data that's equivalent to 8 zettabytes. And if you see the market, this is very important for students or candidates who want to make money in big data, is how much is the market worth? The market is closely worth to about $17 billion, and this is just by 2015. It's currently growing almost $5 billion. If you look at some other interesting points, 2/3 of all the businesses that are surveyed in North America said their biggest primary concern is handling big data. So that gives you a small indicator of why there's a market for professionals in different aspects trying to assist companies, whether consulting or technology implementation or maintenance support, dealing with big data. Moving on. All right, now comes the interesting part. You see a cute elephant picture here. So we heard big data, okay. It has three characteristics. That is, it has volume, velocity, and variety. We understood that companies, yes, because of social networking onslaught and the penetration of internet and the number of people who are actually using internet to be both consumers and producers of data is increasing, and because of which we have this huge amount of data that we need to handle. So that's big data, fine. Now what is Hadoop? If you just take a look at the slide, it's an open source technology, basically by Apache. For people who worked in open source world, they know that Apache group is one of the front runners for all open source technologies, and is a part of their never-ending suite of products and technologies. They came up with Hadoop. Hadoop is basically an open source implementation of a programming concept called MapReduce. MapReduce can be simply summed up as a powerful tool, which is designed for analysis and transformation of large sets of data. That's what Apache Hadoop is. And the elephant in yellow, that's the brand logo for Apache Hadoop. Just to give you an interesting insight, one of the key architects of Hadoop, Doug Cutting, he named the technology Hadoop. He just borrowed the name from his little kid's stuffed toy. The little kid had named the stuffed toy Hadoop, and Doug Cutting, who's a key player in Hadoop, actually borrowed the name from his son's stuffed toy. So that's how the name Hadoop came in. MapReduce was initially based on a technology. Actually, Google was one of the creators of a paradigm. Google came up with an interesting set of observation because as a search company, it ran into the problem of big data initially. Slowly, Amazon and Facebook also ran into problems. Yahoo, same place. So based on the research of Google, they came up with Google file system, which they used, and it was called Bigtable, for them to take advantage of distributed computing. And they actually created a programming technique called MapReduce, which was based on proprietary language. Google, being Google, wanted the world to leverage on the same technology, so they open sourced it and licensed it and gave it to Apache. So the Apache group started working on Hadoop and made sure this technology's API was available for all the people to program. Currently, Hadoop is implemented in Java. I'll take questions on how much Java you need for Hadoop. I'll answer that towards the end of the session. But currently, the key technology used to implement Hadoop is Java. So all you can understand from MapReduce is it's a programming paradigm for parallel processing and handling large sets of data. And primarily, you'll be coding in Java using object-oriented programming principles. Moving on. All right, a quick walkthrough through the Hadoop ecosystem. So when you install Hadoop, again, there are multiple ways. As a part of our training curriculum, we'll give you hands-on training on how to set up an Hadoop ecosystem, starting from a very simple single-node system to a multi-node Hadoop ecosystem. Again, you might be using Mac operating systems or Windows operating systems, or maybe you will go for a cloud-based deployment using Amazon Web Services. It's fine. We can help you with the setup. So just to quickly walk you through the Hadoop ecosystem, this is the whole Hadoop ecosystem, and the core foundation for Hadoop is the Hadoop distributed file system. I'll give you a quick short dive session into this. On top of the Hadoop distributed file system, we have a technology called Yarn MapReduce. This is a framework. When you use a distributed file system, obviously you have to process information from multiple file systems. So it's a distributed processing framework that's called YAN. Like your SQL queries where you say select star from employee and all, when you have data which is being processed across multiple nodes, we use a special type of a querying language. It's almost close to SQL, structured query language, but in Hadoop world we call it Hive. You want to build some statistics out of all this big data processing. There are something called as R connectors. Machine learning is another interesting spin-off of big data. Basically, to clarify what machine learning is. Machine learning is of two types, supervised and unsupervised learning. Whenever you log into any site, the site would provide you recommendations by other customers, or if you log into Facebook, it would say, these are some of the people you might know based on the graphs of your network. That's all, machine learning, where computer has, or the systems have, some data structures and algorithms which, as your data footprint increases, they make some analytics, they do some slice and dice analytics, and they actually say, for this targeted customer, this is the information that would be the right information to be projected. Big data is one of the spin-offs is machine learning, and Mahout is an open source technology, again, based on big data Hadoop, that helps you build machine learning capabilities. You want to write some scripting, could be batch job, maintenance jobs, admin tasks and all. We use Pig. Yeah, the icon is Pig, I know, I'm sure. But that's how Hadoop is built on. They use very funny and easy to pronounce names for their technologies. Obviously, any kind of technology at this scale, you will have to deal with workflows and process executions and synchronizations. That's where Oozie as a technology comes in. If you look on the left side of the ecosystem, you have three primary components. Zookeeper, that is for coordination among all the distributed nodes. You have Flume, that is basically the log collector. You have Scoop, again, all open source technology. This for data exchange. If you look on the right side of the ecosystem, you have Apache HBase. This is for columnar storage. We'll talk about it. This is a special kind of storage that helps you retrieve data very quickly. I don't want to inundate you guys with information right now. And on top here, you would see the Ambari provisioning, managing, and monitoring capability for Hadoop clusters. Basically, this helps you handle the multiple clusters on Hadoop. Not all of them are programming based. Some of them are programming based. Some of them are, for, basically management, administration, log collection. There are multiple concerns which you as a Hadoop consultant can, answer. So we'll talk about it. I'm going to unmute all of you right now, and I'll be open to taking the questions, and that's where we start. All right. Before I unmute you all, I would request that please mute your headsets or machines from your end. And if you have a question, please let me know. I'll go through patiently with each one of you, and do my level best to help you understand the hype and the technology. Okay. With that, I'll unmute you all. Thank you.
Hello, Mr. Sai. Hello, can you hear me?
Yes, I can hear. Go ahead.
Here, Ravi here, Ravi.
Yeah.
Thanks for this introduction. It's very excellent to understand. The question is, the question is, what type of jobs we can look into the market and the categories of jobs. I saw your last slide show, it's showing plenty of technologies, of course, all might same family, but different technology and different purpose for each language or whatever it is tool. But as a employee, what type of jobs I can, what are the categories I can look into this.
Sure, sure.
And yeah.
Very good question. Go ahead.
And what are the technology are required before moving to that for specific category? Can you please explain briefly?
Sure, sure. Absolutely. So in the interest of everyone, most probably, you know, I'll answer this question. So one of the questions is, okay, it's an interesting technology. Yeah, organizations are biting the bullet of big data, and you know, uh, one second, I'll just unmute. I'll mute you guys so that you can hear my voice clearly. Yeah. So I'll just summarize the question from Ravi. Ravi had a question. Okay, this is a pretty interesting technology. Looks like a lot of aspects to this. So, what are the various kinds of jobs it can get on this technology, and what are the different kinds of technologies I need to learn to get those jobs? All right. Let me put it this way. Don't just look at Apache Hadoop. Look at any technology in the world. Maybe some of you have worked in Java world, or maybe you haven't worked at all in any technology. That's also fine. Maybe you came with a SAP background, or you heard people talking about Oracle. Any technology primarily has three aspects, or what we call the Trinity. You either get into a consulting role on that particular technology, you either make your mark as a developer, and last but not the least, you become an administrator. So depending upon your own interest levels and your own capabilities, you can actually pick up three roles: pure business consulting, pre-sales in Hadoop. Especially this is for people who come from a marketing sales background, who understand the basics of Hadoop, and then customize Hadoop for business requirements of their clients. So you can get into that role. You can get into a primarily developer role where you'll be dealing with programming in Java for Hadoop, HDFS, distributed file systems, writing MapReduce programming algorithms, which will distribute the processing tasks and collate them back. You could actually be be HBase or a Hive programmer, or you could actually be a programmer implementing machine learning algorithms using Mahout API. Or you could go into an administrator role where you could be, ensuring all your racks and nodes and clusters are healthy. They are, working the way they are designed to be. There is nothing, maybe handle software and hardware failures, generate scripts, look at the administration tasks, integration with third-party systems, coordination, exchange with legacy systems. So you have three primary channels that you can make a mark in big data Hadoop ecosystems. One, pre-sales, business consulting, selling Hadoop to your clients based on their needs. Two, a developer role where you actually be programming in HDFS, Hive, and different kinds of aspects. Three, you could become a Hadoop admin, who's taking care of all the nodes, clusters, distributed processing systems that are set up, ensure your Hadoop baby is up and running, and you take care of the day-to-day activities. With that, I'm going to unmute all of you so that if you have some additional question on it, you can ask me.
The same question continues with what are the setups?
Can you hear me?
I'm sorry, if you could introduce yourself. Yeah, I can hear you. Please introduce yourself and let me know the question.
My name is Naren. Just kind of curious to know what kind of use cases we have at this time for this technology.
Okay. Wow. Sorry about that. I think somebody's taking this class from near an ocean or something. All right. Yeah. Thanks, Naren. I got your question. Let me just reiterate the question for the benefit of the people out here. So Naren's question is, what are the kind of use cases that a typical Hadoop developer works on or uses? I'll give you a classic example, Naren. Walmart is an online e-commerce major, right? So if you look at that, do you know how many transactions happen in Walmart? Maybe you guys can, ping me. Maybe just ping me. How many transactions do you guys think happen in Walmart every minute? Online transactions. Yeah, Naren, that's right, millions. Anyway, I mean, I think typically it's 10 million. I've been an e-commerce implementer. I work for T-Mobile and Walmart. So, it's millions. How do you handle that kind of data? Now, let's say, I'll give you a classic example. We all know that iPhone 5 is coming, okay? Let's assume we can buy iPhone 5 through Walmart, just a hypothetical example. Don't take me very seriously, but let's assume, okay? Now, how do you think the orders will come for iPhone? Every second? Probably 10,000, 20,000? You guys agree with me? Maybe you can ping me. Take a guess. Yeah? Maybe you'll get a lot of orders. Now, Naren, here's a business case. While people buy the products and, millions of transactions are happening over the products, they would provide their feedback or comments online. Do you agree? Maybe you can ping me. All right. Now, I am the company maintaining, this kind of data. So I need to get some strategic feedback on this data. Now, I need to collect all this data. Probably millions of comments have come on this data. I cannot store this in a normal RDBMS, normal Oracle RDBMS or MySQL, or maybe people say MongoDB, you can use MongoDB NoSQL. But that data, that comment on that particular product is growing by bytes and bytes. It could be unstructured. People might put, pictures. People might, put some text. There is no particular format in which you can say. People might take snapshots of the scratches on the phone and put it back in the comment. Now, you need to query it, and you need to find what improvements you need to do on the product very quickly, and you want this information at the snap of your fingers, but the current technology won't support it. Even if the current technology is saving this data, you cannot run the query and pull the data in the right amount of time to get you the right leverage. And your competitor who sells the same product has Hadoop implementation, which gives them all the analytics slice and dice capabilities quickly. They can adjust to the market need better. That's where Hadoop or its ecosystem of technologies help you. Making sense of big data, finding that critical, maybe you can call a needle of information in this whole heap stack of terabytes and zettabytes of data. Okay, I think one of our students, Shirley, is leaving. Shirley, before you leave, do you have any question that I can answer quickly? Yeah, now I'm open to the question. I think Eugene, you had a question, so I'm going to unmute all. Eugene or Shirley, whoever wants to go with the question, please ask the question. Yep.
So yeah, hi, this is Eugene.
Hi.
Can you hear me?
Yes.
Yeah. So my question is, like big data, cloud computing is like the trend right now, and I was wondering, like there's different companies like Google, like Amazon, they're playing big roles in this new technology. I was wondering, how about for the hardware company, like Cisco, like Intel, like the hardware manufacturing company? What can they do in this new market?
Sure, sure. Okay, I'm just muting everybody. I'll repeat Eugene's question, and I'll answer that question. All right, so Eugene had a very interesting question, right? Okay, big data is hot and most of the companies are doing it. So we have Google, we have Amazon, we have Rackspace, we have VMware, and if you look at the number of companies in the Hadoop ecosystem, they're like growing day by day. So there is a software aspect and there is a hardware aspect. Now, what kind of opportunities we have in hardware aspect, and what do people do? Eugene, you can ping me if I got your question right. Just ping me if, yeah, okay, cool. Thank you. All right. Before I answer Eugene's question, let me quickly tell you, there are two types of scaling mechanisms. Scaling is improving or increasing your computational or processing capability. There are two paradigms. One is a scale out paradigm, and the other one is a scale up paradigm, or you could call it vertical scaling and horizontal scaling. Vertical scaling is where you buy new servers from IBM or Oracle that, you know, give you more processing power. But of course, you have to spend millions of dollars and, of course, renew your licenses every year. So every time you need more processing capability or more crunching capability, you go, you know, buy the big server from one of the big blue companies. Companies like Google, Facebook, Twitter, who are mostly open source and they want to cut their operating costs, they don't want to get tied into a vendor platform. They don't want to be at the mercy of IBM or Oracle or Solaris, who are manufacturing this hardwares. What they do is they go out into the market and buy CPUs off the track. You know, it's like go to the gray market, buy CPUs, buy CPUs, buy CPUs, you know, from a laptop, from a computer, from anywhere. Just buy it cheap and then create a rack, node, and cluster on top of it. So what they do is this is a horizontal scaling, or, you know, scale out paradigm, where you have different processors and then your networking team comes up with any of the topologies to actually connect all these processors. When that big crunching job comes into your technology ecosystem, what we do, or what Hadoop basically does, is it distributes the processing capability. It breaks them into different pieces and distributes it to the different CPUs. When the CPU is done with its processing and all the CPUs in the scale-out mechanism are done with their processing, the whole information is collated, combined back, and sent back to the layer, the colleague layer, which, I mean, it's all abstracted out. You will not know who did the processing or where the processing happened. The opportunities for hardware engineers are to come up with the topology, the connection mechanism, how we can, you know, build a scale-out one. If you work as in Google, probably you'll be working in their data centers, you know, trying to, you know, create racks, clusters, nodes out of this environment. Maybe you might work for VMware, where they have another different way of doing it. So for hardware engineers, it's a very, very interesting time on, you know, how to implement the scaling out. Again, there'll be other aspects like how do you handle failover mode? What if you delegated a job to a particular processor and the processor went down? How do you detect that? How do you redistribute the same job to a different processor? So those are the aspects that the hardware engineers work upon. Of course, they work in close collaboration with the architects of distributed file system. That's where the distributed file system comes into play, where the file system is distributed over multiple CPUs or processors, or we could say racks. And you actually help implement building the big data solution. I hope that answers the question, and I'm open to more questions. I'm just going to unmute all of you. If anybody has a question, you can quickly ask them. Hello? I'm open for next question. Anybody has a question?
This is Eugene.
Yep.
So I have a follow-up question. So thank you for answering for my first question. And my follow-up is, so like currently Huawei has a big growth and big market potential in this market. But I was wondering, like currently, who's the leader? Who's the market leader?
All right, thanks, Eugene. I'll quickly answer that. Yes, that's a very interesting question. So the undisputed market leader of Hadoop, I mean, although they don't say they implement Hadoop in the traditional way, what we are going to see is definitely Google, from whatever my limited knowledge in different company strategies. The next undisputed leader for Hadoop implementation is Facebook. There's the gap between Google and Facebook is so close that you'll not know who's leading at what point in time. But these are the two major players in Hadoop ecosystem, closely followed by Yahoo. These are the companies that actually use Hadoop very well. Yahoo, in fact, was the first company to actually implement it at a big scale, but Facebook caught up very soon with it. As per the vendors, the biggest vendor of Hadoop right now, there are multiple vendors. Cloudera is the company that customizes Hadoop solutions for different vendor requirements. Then followed by a lot of companies, VMware, Fuzzy Logic, SnapLogic. I can keep on naming those companies, but the undisputed vendor implementer for Hadoop right now is Cloudera. I hope that answers the question. Okay. Any more questions?
This is
yeah.
Eric.
Go ahead. Go ahead.
Yeah, from a Hadoop admin's perspective, what are the tools he or she is supposed to learn from an employment point of view?
Yeah. All right. Thanks, Naren. I'll just quickly answer that question for you. So that's an interesting question. Not just for admin, I'll answer it for developer perspective as well. But I'll ensure the admin questions are answered as well. So primarily, if you're looking from a technical perspective, that is implementation and maintenance, as we talked about. So you have a developer role and you have an admin role. Whether you are a developer, you might have to know a little bit of admin basics, and then as an admin, you might have to know a little bit of programming basics. The two key technologies which you need to know, whether you are a developer or admin, maybe depends on the percentage of knowledge, is one is Java, core Java as a programming language, and second one is SQL basics. I mean, Java, again, I'm not saying you have to be a Java guru to handle this, but if you know core Java, object-oriented programming, OOPS concepts, that is one. And the second thing is, if you know SQL basics, the rest all, you can pick up as a part of the trade. Be it scripting, be it, job processing, workflow configuration, analyzing your rack space, cluster needs, hardware failures, software failures. The two key technologies you need to know is Java and SQL query. If you are coming from an admin role, probably SQL and scripting is more important. You need to focus on that. But if you are aiming for a developer role, you need to focus on your Java skills and learning the Hadoop API actually to make the best out of it. I hope I answered the question. And I'm going to, again, unmute all of you so that I'm open for further questions.
For specific administrator, you need only SQL or anything else you need?
There are a couple of other technologies that we need to know. I'll take you guys through it as a part of next sessions. Right now it will be too much of an information load, but if I have to give you a hint, let me just mute so that you can hear my voice clearly. Yeah. Yeah. So if you want further details into this, so this is the ecosystem. Let me tell you what you're going to do. As an admin, you'll be focusing primarily in the left side of the system. Basically, you'll be working with technology on Flume. You'll be looking at Scoop if there are any problems with data exchange. Your focus will be on Zookeeper. This will be a primary area that you'll be working in as admin because this is the heart of distributed coordination. As an admin, you might create some jobs which are purely workflows, escalation mechanisms. It could be scheduled, could be unscheduled. You'll be looking at Uzi. For any scripting technology, you'll be going to pick, but you won't be working too much into this. You'll just be ensuring that the racks and nodes and clusters are up and running, but you'll be using some scripting for a dipstick check. You won't be working in machine learning or SQL query. Maybe you'll just query a bit, to identify how much time the data is coming out, what is the time taken to process it and all. Then you would be learning the setup of Hadoop distributed file system. You'll not be programming over it, but you should be having the basic knowledge of what is an HDFS, how it is implemented, what is a software abstraction level. So these will be the key areas you'll be focusing as an admin. If you are a developer, your key areas will be HDFS, HBase, of course, Hive, Mahout, Pig, and Uzi. But the sequence in which it runs is the reverse way. What is for admin, it's a reverse way for developer. What is for developer the priority, it's in the reverse way for admin. That's how it is. All right. I am going to unmute all of you. If there are any more questions, I'm open to taking it.
This is Naren again. One last question.
Yeah.
Hello?
Yeah, I can hear you.
Yeah. Are the hiring managers insisting on certification for job, real world? What's the situation?
Okay, got it. I'll answer that. That's a very good question. Yes. The answer to the question, how important is certification to cracking a job in the Hadoop space? The answer is yes and no. There are two ways of looking at it. Definitely, if you are Hadoop certified, your credibility level in the market and the resume, your hit ratio for the resume will increase if you have a certification. Again, it's not very difficult to gain certification because it's just starting up, so it's not difficult to get certified. Now, answering the second part of the question, what if I'm not certified? Doesn't matter, because whether you are certified or not, you still have to clear the technical round of interview, whether you go for an admin role or whether you go for a developer role. So yes, certification definitely helps. It's an initial indication. It will at least open the doors for you. Maybe when you put your resume and you say you are certified in the aspects of Hadoop, then probably the recruiters or the headhunters or managers would take more interest. But even though you have the certification, it will not guarantee a job because you'll still have to clear the technical round. But if you don't have a certification, yes, you can take your time and you can plan for, going for the certification, but that should not stop you from applying for the jobs, because if you have the skills, the market is there and the need is there for the jobs. That's the answer to your question, Naren. Yeah, go for the certification, but whether you get certified or not, you still have to show hands-on skills to get the job.
And something good?
Yep. Any more questions?
Rashmi, this is Vinay here. Can I add something to that answer?
Sure. Go ahead.
Hey, from a job market perspective, right now we have Can you guys hear me? Hello?
Yeah, go ahead, Vinay.
Yeah, so from a job market perspective, we need around 2 million people in the next 5 years. There is only 10% of people who know Hadoop and who can program it. So certification is a good thing, but based on the current market needs and what we need in the next 5 years, people will take whatever they get. So I would say first learn the subject, and then if you have time, definitely take the certification. But the demand is so high, they will take whatever they get. So from a hiring manager perspective, they will take anyone who can get the work done.
Yep, that's right. You heard the guy from the field speaking to you. Thanks, Viday, for pitching it. Okay, any more questions? Okay. I guess you guys are done with the questions. Let's still pause for a couple of seconds if somebody has any questions. Okay. We have a question. How many hours is the training program going to be? Depending upon the batch size and all, I'll give you an average. Usually it takes 40 hours to finish off the training on Hadoop. So it will be 40 to 45 hours. And again, we can work on how many hours you guys want to do it on day. Depends on the batch dynamics. Yeah, all the sessions that we take will be followed by hands-on tutorials. We'll be giving you handouts where you can actually do hands-on. We will be setting up either if you want a single load cluster on your machine, or if you wanted a hosted space, we can do both for you. So after every class, every concept that you learn, you will have a hands-out lab training session that you will try to complete it after the class. And once it is done, if you have some doubts or if you need some more clarifications, we help you the next day. Weekends or weekdays, we are flexible to both. Some of the batches that we have taken, we do it on weekends depending on students or professionals' time bandwidth requirements. Some people want to do it every day, so we are open to both. You can talk to Sai and our guys out here. They can help you with all clarity, and we can work out a batch that works for you. We are open both. No problem. I'm from US, so I'm in the US time, so that's not a problem.
Hey, I have a question. Like, if I want to join the session, what are the immediate next steps? How would I join the training session after this call?
Yeah, sure. I'll be sharing you the email IDs that you guys can take, and you can go through it. So I'll be pinging you that. I just want to done with questions. Yeah. So yes, currently I'm working in Hadoop implementation. I have close to 10 years of experience. I've done both cloud computing and Hadoop. This is my second Hadoop implementation, but I cannot share the company details for confidential reasons. But yeah, I can share my insights and I can help you guys. So I have a decade of experience with IT, and the last 2 years is in Hadoop. Yeah. Any more questions? All right. So I hope Sai is there. Sai, I'm giving the control back to you. Guys, we'll just share the training details and rest of the stuff. Sai, if you could, take control and put the contact slide. While Sai is doing that, if you have, if you guys have any more questions, I'm still open.
Hello everyone,
right,
my name is Sai. And, okay. First of all, thanks for attending Instant Learning Technologies free event on Big Data and Hadoop. And moving forward, the next steps would be sending you emails containing the current technical handouts as well as a comprehensive course curriculum. And we just want to emphasize, no matter how small the query you may feel, you can always reach us at Instant Learning 2013@gmail.com, and our contact number is 408-329-6094. And in addition to providing hands-on training, we also offer other value addition services. We will also help you in getting your certification done. And as an instructor already told you, we will also be assisting you in setting up the infrastructure either directly on your local machine, or if you are more comfortable, we can also provide you the server access, which is going to be available 24/7. And one more key feature, which I believe which is close to my heart with regards to instant learning technologies, is we offer customer solution with regards to job support. So we've been there. So like, let's say as a graduate, you get a job. No, it's not just the technical knowledge which matters, but moving forward, every organization is looking towards their employees in terms of value addition. So what they're going to ask you is, in addition to the technical knowledge, they're looking for your domain expertise as well as your unique selling proposition. So we at Instant Learning Technologies, we interact with you, we try to work out a solution, and we provide you specifics, and we'll walk with you till the completion of your like let's say first project. So for further details, you can always reach us at the contact details which have been given here. And I would advise you to check your emails regularly. So once again, thanks for attending Instant Learning Technologies free event on Big Data and Hadoop. That being said, if anyone of you have still some doubts, Rajni is here, so please ask him any questions. Thank you.
Yep, thank you, Sai. If any more questions, guys, I'm still open.
Hey, I have a question for the audience. Did we already check in about who's attending and what their expectation is from the course?
Yeah, I mean, through questions we asked, a couple of people expressed their expectations. Rest of the people, yeah, we'll have to double check. So guys, if you have any more questions in this regard, so we are open.
Yeah, to be honestly, I'm more interested in hands-on experience actually, because this technology is brand new. Even hiring managers doesn't know what to ask. Even if they ask the question, they just Google it and ask the question, but they don't know exactly how the new resource is going to perform at the work. So I'm expecting a very good hands-on experience from this course. So your thoughts?
Yeah, absolutely. No course is complete with hands-on, and at Instant Learning Technologies, one of the key reasons for our success is because for students we give absolute hands-on. So let me give you a small example of how we do hands-on. Okay, so we learn a concept like SDFS. Let's say on a particular class you will learn SDFS. Then what's going to happen is we will set up a cluster based on your computing, infra. Maybe you have a Mac, we'll help you set it up on Mac if you wanted to run it on local. Maybe you have Windows operating system, we'll give you the exact handout and the batch jobs on how to set it up, how to set up the Eclipse plugin, how to configure your Hadoop single node system, multi-node system. If you have multiple CPUs, how to connect them. And if that doesn't work for you and you want something like a cloud-based solution, we have capabilities for working that. So once this whole setup is done, we share the code base through GitHub. We'll give you the code base. Of course, the handout session will have exact steps and a challenge question for you to try out different things. So the exact steps will be, just look at the handout, understand the steps, try to implement it. Of course, I'll be doing hands-on myself during the training, and then I would be asking you to do a hands-on homework session after the class. Next day in the class, we can come back and I'll spend some time with you guys. If anybody is stuck with, oh, I was not able to write that MapReduce to search that particular pattern out of the logs, or like, okay, I had issues with, my single node cluster is not responding, or I have connection issues, I can help you with that. So what we do, and one of the reasons we see hands-on is so critical, is we'll ensure that, as you rightly pointed out, even the hiring managers don't know what they're expecting, but once you hit the job, you don't know what kind of challenges come up. At least, you'll be prepared to handle those challenges because you would have seen them before. So, yeah, hands-on is a very critical part of our training session. So, definitely, you can attend more classes to see how we do hands-on. That's not a problem. Any more questions, guys? Okay, thank you all. I think you have the contact details, and please, keep looking at your emails for further updates from our team here about Big Data Bootcamp and rest of the session. I would like to thank each one of you individually for, taking the time out for attending the whole training course. If not for anything else, I hope you understood that Big Data is the next wave. In IT, typically there are waves every 2 years and 3 years, and you want to make a break or improve your billing hours, billing rate per hour. You got to catch the wave. And right now, if you talk to anybody, they'll say Big Data and Hadoop is the wave that you need to get on to. So I hope this session proved interesting for you and provided you the information that you needed to understand Big Data. Do feel free, as I said and Vinay told you, to get in touch with us. We'll be more than happy to help you guys in understanding and finding your place in the Hadoop world. And with that, thank you all for this opportunity, and you all have a good day. Thank you so much.
The organizer